When it comes to cybersecurity, the best defense is, well, it's often a good offense, one you build yourself with code. Today, we're going to break down why two specific languages, Python and SQL, are pretty much the essential toolkit for anyone serious about protecting the digital world.
Okay, let's just jump right in with a huge number, 33%. According to the U.S. Bureau of Labor Statistics, that's how much jobs for information security analysts are expected to grow between 2020 and 2030. I mean, that's not just growth, that is an absolute explosion in demand.
So, what's the secret sauce for landing one of those jobs? It's really about learning to think like an attacker so you can build a smarter defense. This quote here really nails it. Programming isn't just about typing commands, it's a mindset that helps you understand the logic behind an attack.
And that kind of begs the question, doesn't it? I mean, with all the programming languages out there, where should you even start? Where do you focus your energy to get the biggest bang for your buck in security? Well, today we're going to make a strong case for two absolute powerhouses.
But first, we've got to wrap our heads around the modern challenge. See, cybersecurity today isn't about stopping one big, dramatic hack. It's more like trying to drink from a fire hose, a constant, relentless flood of data, alerts, and potential threats. The sheer volume is the real enemy.
And believe me, the stakes could not be higher. We're not talking about some minor inconvenience. When big organizations get hit, these attacks are incredibly sophisticated. The damage is severe, and the losses, both financial and to their reputation, can be absolutely colossal. So, how in the world do you manage all that chaos? How do you defend against these super high-stakes attacks? Well, you get a massive advantage by learning to code. Programming is like a force multiplier. It lets one person analyze, automate, and defend on a scale that would be totally impossible to do by hand. And let's just be really direct about this. In the security field today, not knowing how to code is quickly becoming a serious roadblock in your career. The industry is evolving, and the problems we're facing now demand the kind of speed and precision that only programming can deliver. All right, so this is where our two essential tools come into play. On one side, you've got Python, the master of automation and scripting. And on the other, you've got SQL, the undisputed king of data and databases. You put them together, that's the ultimate one-two punch for modern cybersecurity. Let's start with Python. The best way to think of Python in security is as an automation engine. Think about all those mind-numbing, repetitive tasks that would just bury a security team. Python handles them at machine speed, and it does it perfectly every single time. And this isn't just theory, We're talking about real, practical stuff, like scripting a network scan to constantly hunt for weaknesses, automatically analyzing a piece of malware in a safe environment, or even building your own custom tools to test your company's defenses. So why Python? What's so special about it? Well, it's what we call a high-level language. All that really means is that it's designed to be easy for humans to read and write. It almost reads like plain English. For a security pro, that's a game changer. It means you can go from an idea to a working script way faster, which is absolutely critical when you're responding to a live threat. Okay, let's switch gears to our second tool, SQL, which stands for Structured Query Language. If Python is the automation engine, then SQL is the data detective. See, every single system event, every intrusion, every attack, it all leaves a digital footprint. SQL is the language you use to sift through mountains of that data to find the crucial clues. Now, to really get why SQL is so important, you have to see how attackers abuse it. The most famous method is called a SQL injection. This is super sneaky. The attacker doesn't kick down the front door. They trick the application on the inside into running their database commands for them. Okay, so picture this. Your login page is like a digital vault, right? A SQL injection attack doesn't try to guess the password. Instead, it sends a tricky little message to the lock itself. A message that basically says, hey, open up if the password is correct, or if 1 equals 1. And since 1 always equals 1, the condition is always true, and boom, the vault swings open. The attacker gets in without ever needing the password. But here's the really clever part. Even if the injection fails and the server sends back an error message, the attacker still gets something valuable. That error often reveals what kind of database is running, like MySQL or Oracle. This lets the attacker fingerprint the system so they can craft a much more precise and successful attack the next time.
So what do you do about it? Well, there's no single magic bullet. It's all about a layered defense. First, you use something called a web application firewall, or a WAF, which acts like a shield to filter out malicious requests. And second, and this is true for almost all of security, just keeping your software and databases patched and up to date is one of the most important things you can possibly do.
All right, let's tie all of this together. When you combine the power of Python and SQL, you're not just using a couple of tools. You're actually building a whole defensive strategy. You're creating a system that's both proactive in finding problems and reactive in investigating them.
If you remember one thing, let it be this. Python gives you the power of automation, handling all that relentless, repetitive work so you can focus on the big picture. And SQL gives you the power of insight, letting you dive deep into the data to find out what's really happening on your network.
And that really leaves us with one last thought to chew on. The future of cybersecurity isn't just going to be about buying the fanciest new software. It's going to be about building the right solutions. With languages like these, you have the building blocks. So the only question left is, what will you create to make the digital world a little bit safer?